Okay, so I am happy, really happy that our first speaker finally arrived. So I'm have an honor to announce the lecture of записується, правда, of Volodymyr Lyubashenko from Institute of Mathematics. His talk is Symmetric Weak Multi-Categories and Biprops. So please.
Thank you. I first of all would like to thank the organizer. How to... I see. Okay, so first of all, the plan of the talk is simple symmetric multicategories, then weak multicategories, then biprops. What is the multi-category? It is some monoidal category where the tensor product is forgotten, removed completely from the consideration. So what remains is the set of morphisms with several entries and one output that, as you see. And there are two kinds of multi-categories, symmetric ones and non-symmetric. The difference would be just to replace in the category of all finite sets with the category of ordered, totally ordered finite sets. So objects will be ordered tuples always, but in the category S, the order is not preserved by the maps. So for any map from I to J, for instance, phi like that, we have a composition map like that. And for any object x of v, we have a identity map which is starts in 1x and also in 1x, the same object x. And naturally, associativity for the composition, mu phi is the composition map, and two unitality maps, two unitality equations are required. So first of all, the associativity which is written for arbitrary maps phi psi. This is the definition of symmetric multicategory. So denoting phi k is this restriction of the map phi to some pre-images. We have such an equation. And identity equation, the right one is formulated like this, and the left one requires substituting several identity maps according to this equation. And now generalization. Instead of a set C from X I tuple to Y, we have a category. As before, we have we have a small set of objects, and for each double xi large family, but finite, and one extra object y, we have a category cxiy. And now the composition becomes not a map, but a functor. From this product of categories to this one. And identity is an object of the category C from X to X. And now, instead of equation of associativity, an isomorphism of associativity. In fact, diagram is the same, only instead of saying that it is commutative, we say that there is a natural isomorphism nu. And also, the equation for the right unitor replaces with a natural isomorphism. And the same for left unitor. So these are data, and they have to satisfy an equation of their own. Here, rectangle means some functor, some with two entries, multiplication and one output, and the diagram is read from top to the bottom, and oval means the source of the natural transformation. So it is not a part of the picture, but part of the morphism. This equation reminds of McLean's pentagon, McLean's star-shaped pentagon, and in fact, it is something of that kind. And also two equations relating unit source and the associator nu. Only one. Just as it is the case with monoidal categories. And what I want to prove, but now it is only a conjecture, that any symmetric big multicategory is equivalent to a strict one, the one which has associators and units identity transformations. In order to do this, I have to introduce some notions which is probe one dimension up. So probe is a particular case of symmetric monoidal category. Biprop is a particular case of a symmetric monoidal bicategory. Maybe biprops are easier to swallow because some structure elements are strict. For instance, the tensor multiplication in a biprop as a bicategory, monoidal bicategory, is strict. And now the definition. Biprop is a bicategory which has the set of objects free monoid generated by set S. So objects are tuples of elements of S, like that. I recall is an ordered finite set. So monoidal products are assumed to be strict homomorphisms of bicategories. And they are introduced for each ordered set L, finite to totally ordered. And strictness means that the following diagram of functor is not a morphism but an equality. There is a commutative cube which is deformed to such a degree that only two faces remain of it, and that's one equation which has to be satisfied, and another is the requirement that units, the product of units is a unit again, this line. And second equation is telling that unitor behaves as you would expect. And there is one more equation for right unitors, which is presented here. And furthermore, there is a family of one morphisms which relate tensor products of objects of AI and iterated tensor product, and this one morphisms must obey the following requirements: that we have a natural isomorphism between such and such one arrows. And this means for any family of one morphisms UI from AI to VI, there are two isomorphisms like that. And in the particular case, when these UIs are identity maps, kappa F is L multiplied with R minus 1, which is the next requirement. And something of this kind about the different requirement if I and if F is an order preserving map from I to J, we have the following equation. So the new two-morphism KF is expressed in terms of right unit and inverse to left uniter. This is not the end because there is one more equation which has to be satisfied by these morphisms KF. Namely, patching of such two squares must be equal to such one. Here, the problem is that we have to compose three arrows, and the composition depends on the order of in which this composition is taken. So in fact, the equation is much more complicated, and you can see it here. This is the same as above, but the associators A and A inverse are inserted. And finally, it is required that if F preserves the order, lambda F is nothing but identity. I recall that the tensor product is strict. And this morphism lambda F lambda G has to satisfy an equation, not an isomorphism, but an equation for each pair of composable maps F and J. So, the good news is relation in one direction, namely, if we have a symmetric weak multicategory, then we can construct a biprop. Ideologically, if we have an operation with many entries in one output, we construct from it operations from with many inputs and many outputs. That to choose has to be a category like that, and by definition it is given by this formula. And the biprop C has objects words in alphabet of C, objects of C. This I already explained, and the composition is given by this formula. The identity is just a table of identities. The tensor product on objects is a concatenation. The unit object is an empty sequence, and the associator for the composition is built from associators for multicategory. Thanks a lot for your attention.
Thank you so much for your talk. Good morning. So we are starting our session of algebraic geometry. We are waiting just a bit for our first speaker, who is just searching our room. So several minutes, yeah, we'll wait. Okay.